All right, this video is going to talk a little bit about reference angles and how we can take advantage of reference angles when we're talking about calculating or finding the value of trig functions of fairly familiar angles. So the idea of a reference angle is actually a fairly simple one. The reference angle is just the acute angle formed by the terminal side of an angle and the x-axis. Now notice they didn't say positive x-axis, right? Just the x-axis. So no matter what quadrant we're in, we're going to take that angle from whatever terminal side we're looking at and draw it straight to the x-axis. So we're talking about this 300-degree angle over here at the left, right? What I would do is start off by drawing an angle. And I know that 300 degrees, again, is going to be 90, goes to 180, 270, and an additional 30 degrees or so. So again, a 300-degree angle is going to be down here in quadrant 4. Well, the reference angle is just going to be the angle, again, directly to the x-axis. So since we went 300 degrees, not a full 360 degrees, basically 360 minus 300 leaves us with a 60-degree angle, and that would be our reference angle. Same thing goes for negative 170 degrees. Again, if we figure out where that's going to be on our graph, probably the easiest way to think of that is negative 170 is going to go again clockwise, but it's going to be exactly 10 degrees short of 180, right? So basically we're going to go around to here, but again we would be down in quadrant 3. Well, since we know we're 10 degrees short of 180, that angle directly to the axis, again 10 degrees, is our reference angle. The same thing works for radians, if we really think about it. 4 pi over 3, well remember pi over 3 is a 60-degree angle if we convert it to degrees. But again, 4 pi over 3 is going to be 1, 2, 3/3, 4/3 will be right down in this area here, again traveling around that direction. But again, how far past 180 or past pi did we go? Well, this angle was basically pi over 3. It was a third of pi past essentially 3/3 of pi, right? So again, that extra 1/3 pi is our reference angle. So let's do one more very quickly here. 5 pi over 7. Well, 5/7 is less than 1, but greater than 1/2. So again, if I remember that this is pi over 2, half pi, and this is 1 pi, 5/7 of pi is going to be somewhere in the middle of there, right? Again, about 1.5 pi past the halfway point. So it's going to be, again, somewhere out in this area. All that really matters is I'm looking for the angle over here. So again, if we're 5/7 of pi to get you from 0 to that point, we're 2/7, right? Or essentially pi minus 5/7 of pi would be 2/7 of pi, right? 2/7 and 5/7 making up a full 1 or 7/7 of pi. So again, our reference angle would just be that 2 pi over 7. Now, why do we care about reference angles? Well, the idea is, and if we want to calculate trig functions, right? Calculate trig functions, we can use the right triangle formed by the reference angle to determine the value of a function, right? To determine that value. Again, we're going to be talking about different quadrants, and we already know that in the different quadrants, again, sine typically refers to the y-coordinate, so there's the ability to have that be a negative value. But if I can draw that reference angle, again, 225 degrees, well, that's around into quadrant 3, and it's exactly 45 degrees into quadrant 3. Well, if that's the case, if I can draw a 45, 45, 90 triangle here, I went left and we went down, so we'll call those negative ones. Again, a hypotenuse of root 2, 1, 1, root 2 being a 45, 45, 90 triangle. And what we can say is, well, the sine of 225 isn't going to be just the 45-degree angle, right? Because the sine of 45 degrees would have been a positive value. But the sine at 225 would be the opposite over the hypotenuse, or negative 1 over root 2. The fact that that negative is built in, right? And again, multiply the top by root 2, bottom by root 2. The fact that that negative is built in means that this is the sine of 225 degrees, right? We're not just 45 degrees, but the ratio will be the same as the sine of 45 degrees only now it's negative, right? We're down in quadrant 3. Let's do a couple more. We've got the cosine at 11 pi over 6. So again, if we imagine where 11 pi over 6 is here, well, that's almost 12/6, right? It's almost a full 2 pi. So again, we're going to go all the way around over here. We're setting ourselves up with a triangle over in quadrant 4. And we're exactly 1/6 of pi, or essentially 30 degrees, short of, right, a full 2 pi. Again, pi over 6 would be, again, opposite of 1, hypotenuse of 2, square root 3 for the other leg. And because we went downwards, that's actually a -1. Cosine would be adjacent over hypotenuse. And again, because we went right, I'm not worried about the negatives. Cosine is like the x value. X's are positive down in quadrant 4. Well, I've got my value, or my trig ratio, right there. And finally, the tangent, well, same idea. If you can draw the triangle, you can find the ratio. So -4 pi over 3. Well, hey, if I go pi over 3 is a third, right? Or essentially 60 degrees, third of 180. So I'm going to go 1, 2, 3. Again, that's a full pi. 4 would put me up in quadrant 2 here. But again, thinking about a 60-degree angle, pi over 3 angle. So again, this is 1, this is 2, and this is square root of 3. Remember, we went upwards, so root 3 is positive. We went left, so 1 is negative. And just realize that the hypotenuse is always positive. Again, it's not measured on x or y, right? It's just another distant line. So only x or y, only the legs will ever be negative if you approach it this way. So in that case, the tangent, again, is opposite over adjacent, or basically root 3 over -1. Or if we cleaned it up just a little bit, negative root 3. Again, I hope that helps you with reference angles. It also tells you why we work with reference angles. If we can draw our triangles, the trig function of any angle, right, will be the same as its reference angle, a trig function of its reference angle. The only difference might be, again, the signs. It might be positive or negative comparatively, right? Tangent at 30 degrees would have been root 3, right? Or sorry, at 60 degrees, right? 60 degrees would have been root 3. But the tangent at a -4 pi over 3, right, up in quadrant 2, well, tangent's always negative in quadrants 2 and 4. So again, the only difference is that negative. Again, if you have any questions about that, talk to your teacher. Otherwise, have a great day.